right, so we're on to Unit 2. Unit 2 is transformation, so that is translations, rotations, reflections, and then dilations. There's not going to be any dilations on y'all's final exam, or the midterm, so don't worry about that, but we do need to talk about the rest. So, first we have a problem that says, describe the transformation in the coordinate notation. So remember, transformation, that is all our transformations, okay? So that can be any of the three, any of the four if you include dilations. But looking from this shape to this shape, I know that we are just sliding that, okay? So it's just being slid. So that is a translation, okay? So translations are probably the easiest. We're just going to be able to count how I'm moving, how I'm sliding that shape. So remember, I want to start at just the plain old A, because that is my pre-image. That's where we want to start. And then I want to start at my A prime. So A prime with the little apostrophe, that means prime. A prime is going to be my image, okay? So that is where I'm going to end up. So I want to go from pre-image to image for every one of my transformations, okay? So now all I'm going to do is I'm going to count. So I have from A to A prime. So I'm going 1, 2, 3. So I'm going 3 up. So 3 up, okay? And I'm going 1, 2, 3, 4, 5. I'm going 5 left. Label that. Okay, so I'm going 5 left. Okay, so it could work from any point. If I wanted to go from B to B prime, it'd be the exact same, or C to C prime, the exact same there. So it's going to be the same translation no matter which point you start at. So I want to write this in coordinate notation, okay? So coordinate notation means I'm going to have my x and my y's, and then I'm going to have some combination of negatives and or numbers. So this is a translation, okay? So my translations are going to be x, and I'm going to have some number, and then I have y, and then some number, and then in parentheses. So all it's saying is how much did I move each thing? How much did I move x direction and how much did I move y direction? So up, that is a y direction, right? Up and down, that's y direction. Okay, so up would be positive, right? So I'm going to have plus 3 because I'm moving y direction up 3. And then left, that is an x direction. Okay, the left is a negative. You can always tell negative because I'm going into the negatives, right? I'm getting closer to my negatives. So, since I'm going 5 left, I'm going to go minus 5. And that's it. That's all my coordinate notation, okay? And then my next problem says a point is located at 2, 3, which reflection maps it to point negative 2, 3. Okay, so remember reflections, that's my second transformation, they are flipped. Okay, so we are flipping this point across some line to get to this point. Okay, so first thing I should notice about these 2 points is that my y coordinates, they are the same. So my y coordinates are the same. So if my y coordinates are the same, that means that I am reflecting across an x equals. So I'm going to reflect across x equals. Then reflect across x equals. Okay? Or we have an x equals that's sometimes a little sneaky. X equals is also the y-axis, because the y-axis is x equals 0. Okay, so it could be either any kind of x equals, but it could also be the y-axis, which is x equals 0. Okay, so I'm looking at my point. So I'm going from 2 to negative 2. Okay, so I want to think, what is that distance between 2 and negative 2, right? That is a -4, yes? So I know that to get from one side to the other is going to be 4, right? Well, I know somewhere in the middle is the line that they're reflecting across. So I have to think 4 divided by 2, that gives me 2. So in a distance of 1, 2, that should be my line. So if I look there, I have 2 minus 2, which gives me 0. So I know it should be an x equals 0. And we also call x equals 0 the y-axis. So we are reflecting across x equals 0, or the y-axis, okay? So make sure that when you're doing problems where we just are given 2 points and we're looking at reflection, we want to see which points are changing. So if I'm changing my x's, then I'm going to reflect across an x equals. If I'm changing my y's, then I'm going to reflect across a y equals. And then I want to find what is the distance between those 2 changing points. So what is the distance between my 2 and my negative 2? And then what is that midpoint? Because where the midpoint is, that is where my line of reflection will be. Okay, so it will always be on that line of reflection when you have the midpoint. Okay, so the next one is a rotation. So we have, what will the coordinates of the endpoints of the segment be after a rotation about the origin of 180 degrees? Okay, so we always rotate it around the origin, at least for this unit. So we want to do 180 degrees. So I got to think. So my rotations. So if I rotate 90 degrees, so remember, that tells me how many quadrants I'll be jumping. Okay, so if I'm rotating 90 degrees, I am moving 1 quadrant. Okay, so I would be going from here to here. And that would be from x, y to negative y, x. Meaning that my old x becomes my new y, and my old y becomes a negative new x, okay, which makes sense because if I move this point positive, positive, it's going to move into negative, positive. So I want a negative x and a positive y. Now, the one we're going to be using is 180 degrees, which means we move 2 quadrants. So I'm going to go 1, 2, 180 degrees. So that's going to be xy to negative x, negative y, which makes sense because, again, we're moving 2 quadrants. So what quadrant is this? It's the double negative quadrant. So if I move from here to here, I'm going from positive, positive to negative, negative. And then my last one I'm going to talk about real quick is if I'm moving 3 quadrants, I'm going 270 degrees. So this one is like my 90 degrees, and that I flip my x and my y. So I'm going to do x, y goes to positive y, negative x. Okay, so it's saying that I'm going to go 3, which makes sense, right? Because I have positive x's here, so that would be my positive x, and then negative y is here. So if you can remember that 90 degrees and 270, we just flip, then you can just count which quadrant I should be in and know where should I have negative and where should I have positive. Okay, so for this problem, we're going to use 180 degrees. Okay, so all I'm going to be doing is changing my points to negative. So let me get my points first. So let's call this A, and let's call this B. So A is at 4, 5, and B is at 2, 2. Okay, so I'm going to take A, which is 4, 5. I'm going to take it, and I'm going to rotate it. So A prime, my image, and I'm just going to change them to negative. So I'm going to do negative 4 and negative 5. And then B is 2, 2. So I'm going to change B to B prime, and that's going to be negative 2, negative 2. And that's your answer. That easy. Okay. So the next one says that I have triangle ABC has coordinates of A, -1, 2, B, -4, 8, and C, -7, 2. The triangle undergoes a translation, so remember we're sliding, described by the function xy to x plus 6 and y minus 5. So what would my coordinate for B prime be? So I am just looking at B. That's the only one I have to work with. So here I'm going to do B. And B is at, let's see, -4, 8. Okay, so we are translating -4, 8. So the great thing about translations is all I got to do is take these numbers. I already have my coordinate, but I want to change it into x plus 6, y minus 5. I have an x, and I have a y, so I'm just going to plug them in. So that means that B prime is going to be -4 plus 6 and 8, minus 5. Okay, so B prime, -4 plus 6, that's +2, and 8 minus -5, that is 3. So B prime is going to be 2, 3 after a translation of x plus 6, y minus 5. Okay, and that's it. So the next thing says describe the composite transformation from triangle ABC to triangle A prime, B prime, C prime, and triangle A prime, double prime, B double prime, and C double prime. So, i.e. coordinate notation, reflection across the line, rotation of x degrees. Okay, so we want to basically say what's going on from my original, my pre-image, to my first image, and then my second image. So let's start here, right? This one's my A, so that's where I'm going to start. So that's triangle 1. This one's my A first prime, so that's going to be triangle 2. And this is A double prime, so that is going to be triangle 3. Okay, so first thing I want to do is what is my translation or my transformation from 1 to 2? It is a translation though. So we are going from this triangle to this triangle. So either you could look at my points and see how they change, or we have a graph, so we might as well use it and go ahead and count. So I'm going to just go from B to B prime. So it doesn't matter which points you go, but as long as you are going from the correct letter to the correct letter, you'll be okay. Make sure you don't mix it up. Don't go from C to A, okay? So from B to B prime, I'm going to go 1, 2, 3, 4, 5 down. So I'm going to go ahead and write that right here. 5 down. And then I'm going 1 left. Okay, so that means I'm going to go from X, Y, 2. Now remember down, that's Y. Oops, 1 left. And that's X. So my X, and then left is negative, so -1. Down is negative, so I'm going to do Y minus 5. So that's my first transformation. It is a translation. And then from 2 to 3, okay, notice how it's being flipped, right? It's completely flipped across. So I know that has to be a reflection, okay? So what you want to do to find reflection is I want to find the midpoint, because if I find the midpoint, then I can find my line of reflection. So I'm going to go ahead and go from C prime to C double prime. So I have 1, 2, 3, 4. So 4 is my total distance, which means that 4 divided by 2 is 2. So 2 is where my halfway point should be. So 1, 2. So there is my midpoint, which means my line of reflection should be that line that runs through that point. Okay, and that just so happens to be my my y-axis, which is also x equals 0. So I'm just going to go ahead and say reflection across the y-axis, or x equals 0. And that is it. So now we're going to talk about lines of symmetry. Okay, so lines of symmetry, we're talking about reflectional symmetry. Okay, so this is reflectional symmetry. So when I'm looking at my shape, I want to see a mirror image on either side of that line of reflection. Reflectional symmetry. Okay, so we're looking at a rectangle that is not a square, meaning that I have two sides that are equal and another two sides that are equal, but not all four of my sides are equal. Okay, so my rectangle looks like that. Okay, so I only have a line of reflection here, right? Because if I were to take a mirror, they'd be perfect, right? Perfect matches for each other. And then I have one right here because, again, if I fold that in half, they are perfect images of each other. So notice, here's another rectangle. If I do a diagonal line, those aren't perfect mirror images of each other on either side. So that does not work. I can't go diagonally with a rectangle because I have two equal sides and another two equal sides, but don't have all four equal sides. So if I did have a square has all four equal sides. So I could do this, I could do this. Ooh, sorry, those are a little off. Pretend that those are in the center. I could do diagonally because on either side of a square, you're going to get two perfect triangles, okay? And then I could do this. So I would get 4 lines of symmetry, whereas my normal rectangle gets 2. So a good thing to remember is if you have equilateral shapes, polygons, okay? So if I have an equilateral triangle, or I have a square, or if I have a regular polygon, something that has all the sides equal length. However many sides you have then, that's how many lines of reflection you have, okay? But that's only for regular polygons, only saying that they have all sides equal. Rectangles don't have all sides equal, so I would only have 2 here, okay? All right, then we get into rotational symmetry. So rotational symmetry is a little different in that what we need for rotational symmetry is we need how many times do I rotate it to get a picture that looks exactly the same as my what I'm looking at right here, okay? So I need at least 2 lines of symmetry for it to have rotational symmetry. So if I don't have at least 2 lines of symmetry, that means I'm going to have to rotate it a whole 360 degrees all the way around in a circle before it looks exactly like it looks as it is right now. Okay, so let's look at my letters. If I'm looking at A, I want to see how many lines of reflection I have on A. So I know I can cut it in half, and those are mirror images. So that's the only one I can do that with. So I have 0 lines of symmetry, zero reflectional or rotational symmetry here. I don't have any reflectional symmetries, no reflectional symmetry. For this E, again, I have 1 line of symmetry, but I have no rotational symmetry. Okay, so no rotational symmetry for that. Now for the I, this might be a little hard to see when I'm going through it like this. So if we were to cut that in half, pretend my pen is a lot thinner, and then I cut it in half this way, I have 2 lines of symmetry for this one. So that means that I do, in fact, have rotational symmetry. So for Y, again, I can cut that in half like this, but I have no other lines of symmetry, so I have no rotational symmetry there. And then Z, I don't have any lines of symmetry. Okay, so I have no rotational symmetry there. Right, so the only one that had rotational symmetry was the letter I, okay? Because I had at least 2 lines of symmetry. All right, so next I have triangle A prime, B prime, C prime. The image of triangle ABC after reflection. What are the coordinates of the midpoint of segment B prime? Okay, so I want to know what are my midpoints between B and B prime. Okay, so basically, what am I reflecting across? Okay, so here's from B prime to B. Okay, so I'm going to go ahead and count. So we have 1, 2, 3, 4, 5, 6, 7, 8. So my total distance is 8. So I want to find the midpoint. So I'm going to divide by 2. So that gives me 4. So the distance to my midpoint is just 4. So 1, 2, 3, 4. So my midpoint is right here. And it asks for the exact coordinate of the midpoint. So I'm going to go ahead and say my x is 0. And my y is at 4. So my midpoint is 0, 4. Now, if I wanted the line of reflection, I could say that it's reflected across my y-axis again. So y-axis, or x equals 0. Okay, which makes sense because look, what does my x-coordinate equal? It equals 0. All right. Now, that is the end of Unit 2 for this review, and we'll begin Unit 3.